everyone, welcome back to Abra Knowledge channel. We're going to discuss 6 real-time case studies on hypothesis testing, and it is more from the statistic perspective. Using Excel formulae, and also we're going to discuss through Minitab software. And this seventh video on hypothesis testing, and we'll be using ANOVA, analysis of variances, chi-square, one or two sample t-tests we will be using it. And the books which I have referred for this one to make these case studies, Juron Quality Planning and Analysis for Enterprise Quality, and Statistic for Manager, 10th edition as such. Case number 1. And sanding wood component is often done on a machine called time saver sander. The reference surface is the flat belt that takes the product into sanding area. For uniform sanding of the wood surface, the part must lie reasonably flat on the time saver belt. At regular intervals, the flatness is checked at an inspection station prior to sanding. The project team investigating whether or not the product flatness could be leading to defect decided to verify the ability to measure the flatness. The data has been given, and all we need to do is we need to check the hypothesis of this. So this is the one which we will be doing it in the Minitab. I'll just quickly show you. This is the person called Kurt, Michael, and Sherry. All these values are being given, and there are different parts are being measured. So these are all the parts being measured. There are you have 20 parts are being measured. Each part is being measured twice, right? That means you have 60 readings and taken by three different appraiser. We'll be seeing it not from the GRR perspective, but from the analysis of variance perspective, we will be seeing it. And then case number 2. Case number 2 is an interesting one, and it is given in the book. You are the manager of a fast food restaurant. The business problem is to determine the population mean waiting time to place an order has changed in the past from its previous value of 4.5 minutes, right? From the past experience, you can assume that the population standard deviation is 1.5 minutes. The standard deviation and population waiting time is normally distributed. You select a sample of 25 samples, an R period, and sample mean is 5.1, and determine whether there is an evidence that the population mean value waiting time to place an order has changed in the past, 5.1 to 4.5, right? Has changed in the past from its previous population mean, that is 4.5. So the step number 1 is we need to write down that 4.5, right? And we just assume that there is no change, right? Null hypothesis statement. Population has not changed from its previous value. That's 4.5. And then that's what, if it is not, if it has been proven, that's called alternate. And then sample mean is 5.1. And N plays a major role. So N equal to 25 sample. That is step number 2. And step number 3 is level of significance. As I said in the past video, you can keep it like 0.05 or 0.01, whether if you wanted to have 95%, and then you can give 0.05, that is 5%, right? And depending upon that, you can change it. Here we are keeping like 0.05, and standard deviation is 1.2, right? And there is first we need to step number 4. So this has been computed from this one, and 4.5, 5.1, 25, and 0.05, and 1.2. And from this, you can easily find out Z stat. E4 minus B4. E4 is what? 5.1 minus 4.5 divided by E6. E6 is nothing but standard deviation, right? And square root of that one, that standard error of mean, right? Standard deviation divided by square root. And the same thing goes in the denominator, right? Standard deviation divided by square root of C5. C5 is nothing but the N value, right? Or if you want like standard error of mean individually also, you can find out. How? So you can find out like first standard deviation. So this is standard deviation. and divided by square root of number. So n equal to number. Okay, the same thing we have substituted here. So simply what we have done is, so we have just minus these two. Maybe I will do it here. 5.1, and that's a sample value, and 4.5, and then this has been divided. So you get the same value, right? Either you can go with the z stat value, or you can do this way also. Any one of the method you can follow. And p value is actually, the formula is 2 into, because we are talking about 2 proportion, right? So 2 into 1 minus normal distribution, and you need to get the C7 value, that is Z stat value, and true. So you get this 0.01. 0.01 is less than 0.05, of course, right? And in other words, this p value is, if it is less than or equal to 0.05, we need to reject the null hypothesis. That means there is a difference. 4.5 is the time is being taken, right? This is how you can do it in Minitab. So conclusion is, reject null hypothesis. Yes, there is an evidence that waiting time has decreased from 5.1 minute to 4.5 minutes. That's the conclusion we can make from this statistic. So let's go to case number 3. Case number 3 I have already done in the past. I will quickly show you one more time. And cabinet maker was experiencing the keying error, and this is the good and bad. And all you need to do is, you need to use chi-square test, and then you get the value. So for example, here 4.3. 4.3 mean we reject the null hypothesis, right? So if it is 4 less than or equal to 5, we need to reject the null hypothesis. It is, in this case, 87. That means we need, there are two cases are there. On the left side one case, and right side is one case. So in this first case, we reject the null hypothesis. In the second case, we need to accept the null hypothesis. Accept the null hypothesis meaning like there is no change. Let's go, because I have already done it in the past. So I'm just skipping this case, and then I'm just going to H4. The production supervisor thought that the circuit response time had to do with something type of circuit. It is just a hunch, or he wants to know for sure if that is a true. And it is coming from the Juran book, page number 599. So this is the one which we will be doing it in the Minitab. Let's go to the case number 5. A Six Sigma project team is trying to determine if a treatment outcome for a particular illness depend upon the hospital where patient underwent treatment. The table below shows the number of patients who underwent the treatment in each hospital last year, the corresponding patient outcome, full recovery, partial recovery, or no recovery. And this is also coming from Juran book. And we need to do that test for independence test. So this is the value which we will be doing it in Minitab. Directly I will show you in Minitab. And then the last case is the one. And there are customer is corporate, individual, and government. We need to do all are independent or different. So which will also will be doing in Minitab. Let's go to Minitab. Let's do, there are 3 case studies we will be doing it. First had to do with the response time, right? So this is the case studies we will be doing it first. Yeah. So the production supervisor wanted to know that circuit response time had to do with the circuit type, right? So the first case. So in this case, we can use variable ANOVA, right? You can go to ANOVA, and you can go one way ANOVA. And in this case, what we can do is, so this is the response time. So response data in one column, because it is the individual column. Response, this is the response one, that is C13. And factor, the circuit type, that is C12. and I'm going to do that comparison. So 95% confidence, and I'm gonna do it. Okay. So in this case, you can see that the response time of one, maybe we can see both the things. The response one is, this is ANOVA, analysis of variances. First one is, you can see here, the value is 20.8, followed by the second value, that is 28, and third value is 18.4. You can see that whisker, it is starting from 15 and all the way it is going to 23, and then similarly it is starting from 22 all the way to 33, and the last one is 15 all the way to 23, right? Very importantly, if you just flip this one, we can get the p value also as well. Just scroll down a bit, just scroll down, you will find this p value also as well. So here in this case, p value is 0.046, right? So 0.046, as you can see here, 0.046 is nothing but, maybe what I will do, 0.046, I will just enter here, I will come back to the Excel, and 0.046, right? 0.046 is nothing but, it is only less than 5% or exactly 5%, right? So in the 5% meaning, like, again we need to reject the null hypothesis, and we are concluding that the response time have to do with the circuit time. So that's the conclusion we are making in this one, since the value is 0.046. And let's go to the next case studies. This is again depend upon the data, you need to choose the tool differently. This is actually full recovery, partial recovery, no recovery, and this is more of a discrete data you have, right, and a countable data you have. So you need to use chi-square. Time series, sorry, you can go to table, and then you have a cross tabulation and chi-square. So in this case, I have just selected A to D, right? A to D, and then give OK. As you can see that it is the chi-square value has come, and the p value is 0.02. That means 0.002. 0.002 mean, so this is the case study which we are discussing it. We are getting it 0.002. That is just 0.2. This below then alpha value, that is 5%. What we need to do is we need to reject the null hypothesis, and what we are concluding is the type of treatment the patient underwent the treatment, it depends on the hospital, whether full recovery or partial recovery or no recovery is depend upon the hospital. And let's go to Minitab again. Let's do the last exercise, right? So again, so here this is the data I have. I can use very well the ANOVA once again. Why? Because there are three data up there, right? Analysis of variances and one way, and in this case I'm just selecting it each factor, and in this case Kurt, Michael, and Sherry. Give OK, and it has given that value also as well. The graph has come, and it is given that Kurt. So if you can see, more or less they're same. Mean 1, and Michael is 1.05, and Sherry is 1.017. Let's see the p value. That is what very important value. If you scroll down, the p value is 0.927. That means 92.3, right? What we'll do, we'll go back to this Excel. So in this case, the p value we got 0.937, right? So 93.7, 92.3, sorry, 92.3. 92.7. Okay, so 92.7. That means we are accepting the null hypothesis. Whether is occurred or Michael or Sherry does, the process is same. So we do not reject the null hypothesis. The value are same. They are not different. So this is how we can easily remember the null hypothesis and alternate hypothesis. I hope this video is very useful and insightful. Please do like, share, subscribe to the channel. You have wonderful day ahead.